changes in pressure can have a large effect on equilibrium system containing gaseous components. A change in pressure has a negligible effect on liquids and solids because they are nearly incompressible. Let's consider the two possible situations for changing the volume of the reaction vessels. The first situation is the reactions in which the number of moles of gases changes. In this reaction, there is 2 moles of ammonia, which is the reactants, and 4 moles of nitrogen and hydrogen for the products. Suppose these 3 gases in a piston, we pull up the piston to double the volume, the gas pressure will decrease. So, increasing the volume of the vessels will decrease the pressure of the gas. We assume that the gas in this system are an ideal gas, and since P is equals to nRT over V, when the pressure of the gas is decreases, the number of moles of gas molecules per unit volume is also decreases. To reduce this disturbance, the system responds by increasing the number of gas molecules in order to increase the pressure. And the only way to do that is through a net reaction towards the side with more moles of gas. So in this case, towards product, which is to the right. Thus, the concentration of the product is increases and the concentration of reactants is decreased. In terms of the equilibrium constant, a change in volume is in effect a change in concentration because an increase in volume will reduce the concentration. Therefore, like other changes in concentration, a change in pressure due to the change in volume does not alter the value of K. If we press down on the piston to half the volume, so the gas's pressure will double. Decreasing the volume will increase the pressure. When the pressure increases, the number of moles of gas molecules per unit volume also increases. In order to reduce this disturbance, the equilibrium position will shift toward the side with less number of moles, which is in this case to the left, in order to decrease the pressure. Thus, the concentration of the reactants will be increased and the concentration of the product will be decreased. The value of K does not change when we increase the pressure of the system. The second situation is the reactions in which the number of moles of gas does not change. For the formation of the hydrogen iodide from its element, we have the same amount of gas on both sides, which is 2 moles of gaseous reactants and 2 moles of the gas product. Therefore, QC has the same number of terms in the numerator and denominator. Because a change in volume has the same effect on the numerator and the denominator, there is no effect on the equilibrium position. So, increasing the pressure or decreasing the pressure, the equilibrium position will remain unchanged.